Good morning, everyone. Let us start with today's session. So this is lecture number 8 of the engineering mechanics. So in this lecture, we will cover one live problem on one pulley system, and then we will start with the law of parallelogram for the concurrent force system. So during the last lecture, we were discussing about the resultant of the concurrent force system, then steps to find out the resultant and the representation of the resultant. Okay, I have given you one homework problem. So this is the homework problem. I hope you must have tried this problem. So I will write the answer. The question was, if the resultant of three concurrent forces is vertical, and then determine the F, that is the unknown force in this cable, and also determine the resultant. So we need to use two equations. One is resultant is equal to the summation Fy, as the information given about the resultant, that is resultant is vertical. So meaning of resultant is vertical is there is no component of resultant in the x direction. So component of resultant in the x direction will be, it is nothing but the Rx, and Rx is nothing but the summation Fx. So therefore Rx is 0, that means summation Fx is 0. And the y component of resultant, that is nothing but the Ry, it is equal to summation Fy, and it is nothing but the total resultant. So this is the equation for the resultant. So by using the second equation, the summation Fx is equal to 0 or Rx is equal to 0, we can find out the value of unknown force F. So you have to resolve the forces, force 25, then 40, and this F. Then write down the equation for summation Fx, equate this equation to the 0, and then find out the value of force F. So you can check the answer. The F value, it is equal to 8.27 kilonewton. And the second equation, R is equal to summation Fy. So by using this equation, we will get the value of R, that is the resultant. It is equal to minus 41.92 kilonewton. So what does this negative sign indicate? That means the resultant is acting in the downward direction. So we can write this value as a 41.92, and we can show the direction of the resultant in the negative y-axis. So this is your final answer. So I hope you must have got this answer. F is 8.27 and R is minus 41.92. Is it clear to you how to solve this problem? So just you have to use this equation, summation Fx and summation Fy. So now we will start with this problem. So this is one arrangement where two masses, one is 200 Newton and second is the 400 Newton. They are connected to this cylinder with the help of a rope and pulley arrangement. So these are the pulleys. These are fixed to the wall. This is the second pulley. It is again fixed to the wall. And this rope, it is passing over this pulley. And pulley is frictionless. There is no friction. And we have connected one weight of 400 Newton and second weight is 200 Newton. And for this cylinder, the total weight W, it is equal to 800 Newton. So refer the question. If theta is equal to 30 degree, then determine the direction of the motion of the cylinder and net force acting on the cylinder. So what is meaning of direction of motion? Means first we have to find out the net force acting on it. That means the resultant force. So net force meaning it is nothing but the value of R acting on the system. And second, we have to find out the direction of motion. So direction of motion, it will indicate the direction in which resultant force will act. In that direction, complete system or this cylinder, it will move. So we have to find out the angle theta for the resultant. So this direction of motion is nothing but the theta for this resultant force. So how to find out this? For that, we have to draw the free body diagram. So this is a new concept, free body diagram. So probably you must have studied this concept maybe in your 11th or 12th in the physics. So what is meaning of free body diagram? In short, it is written as a FBD. So this is called as a free body diagram. Free body diagram means when we do the force analysis in the mechanics, then we will separate out the object from its surrounding, and then we will only show the forces acting on that object. So this is called as simply a free body diagram. So this complete, it is the system. In this system, we have one object that is nothing but this cylinder. And this cylinder, it is subjected to different forces. So right now, the force is not visible directly in terms of a vector. In the previous problems, there was force given as a vector, and then we perform the force analysis. But nowhere in this diagram, force is directly visible. So we need to visualize that force in terms of a vector. So how we can visualize this? So we will draw only the FBD for this cylinder. That means just separate out this cylinder, draw the diagram only for this cylinder, and then show forces acting on that cylinder. So this is the cylinder from this system. Now observe the first force, which is nothing but the 800 Newton. So what is the direction of this 800 Newton? Right now in this figure, this weight force is not visible. That means we have to imagine that direction of this weight force. So you know the weight force always act in the downward direction, vertically downward, okay? And weight, it will act from the center of gravity. So for the circle, center of gravity will be exactly at the center. So I will show that force from this point exactly in the downward direction. So this is the weight vector. So this force is nothing but the W, that is equal to 800 Newton. And exactly acting in the downward direction, that means it is negative Y direction. Now second force, it is the force or the tension which is developed in this cable. So this tension, its direction will be like this. It will try to pull this center point in this direction. And this tension, it is created because of the 400 Newton force, or the weight which is connected to this cable, whose value is 400 Newton. So this force, it will transmit through this cable up to this point. So this is the direction of that tension. So now vector is visible. So we have to show the vector along the same direction of this cable. So I will draw only the force by using a vector like this. No need to draw this complete diagram. So we know that this 400 Newton means what? It is the force vector, or it is a tension in this cable. So just show this. I will represent that tension. So just take this tension as a tension 1, and its value, it is equal to 400 Newton. So when there is a frictionless pulley like this, then the tension or the force on one side will be transmitted as it is on the other side. So we are taking the same value T1, that is equal to 400 Newton. Now observe the second diagram. On the other side, we have 200 Newton object, which is connected to the cable, and then it is connected to the center. So this cable is exactly horizontal. So this 200 Newton, this is the direction of tension. So it will be the same direction here along this cable. So we will assume this tension as a T2. So just draw one horizontal vector, and this value, it is T2, that is equal to 200 Newton. Now this system, it is a concurrent force system, because T1, T2 and this W, three forces, they are meeting at a single point. So this is called as a point of concurrency. So now we have to take theta is equal to 30 degree. So just draw one x and y axis. So this is just for our understanding. So this is x axis, this is your y axis, and this angle, it is theta, that is equal to 30 degree. And now we have to find out the net force. That means we have to find out the value of the resultant R. So the steps, first step is we have to resolve the forces. So for the resolution, let us assume T1 is 400 Newton. You can select any point on this line. So select this point, draw the vector parallel to y axis. So this will be your y component. Draw the second vector parallel to x axis. So this will be your x component. This angle is theta. So this angle will be theta. So this component, that is the adjacent component. Okay. So this will be T1 cos 30. And this y component, it will be opposite component. So this will be T1 sin 30. Now T2 component or T2 force, do we need to resolve this force 200 Newton? Just you can give the answer. Is there any need to resolve the T2 force? So this T2 force will remain as it is, 200 Newton. It is along the x-axis. This W force, it will remain as it is. It is along the y-axis. Now second step, we have to write the summation Fx and summation Fy. So first take summation Fx. Now for the summation fx, consider the forces acting in the x direction. So we will start from the T1. So what is x component of T1? It is T1 cos 30 and T1 value is 400 Newton. So it is 400 cos 30 and it is acting along positive x direction. So this will be plus. Now second component along the x direction, this T2 force. This T2 is completely acting in the x direction. So consider this force only in the summation fx. Do not consider T2 in the summation Fy. So I will write here 200 Newton and it is acting along negative x direction. Therefore, it is minus. So this 200 means what? It is completely x component. So we have only two components. One is 400 cos 30 and second is the minus 200. So you can get this answer. Now second, write the summation Fy. So for the summation Fy, for T1, this is T1 sin 30. So T1 is 400. This is sin 30. And it is positive y direction. Second component, there is no component of T2 in the y direction. There is a component W in the y direction. So take this component minus 800. It is completely acting in the y direction. So value is 800 and it is negative. So find out the summation Fy. So if you have the calci, you can solve that. So the first answer for summation fx, it is 146.41 Newton. Just check the answer and it is positive. That means your summation fx, it is directed towards the positive x direction. For summation fy, it is minus 600. Just cross check the answer. So minus means what? Your summation Fy is 600 Newton and it is acting in the negative y direction. So why this direction is important? Because we have to find out the direction of the motion of the cylinder. That means we have to find out this theta for the resultant R. And for that, we have to locate the quadrant of the resultant, whether it is first, second, third, or the fourth quadrant. So this quadrant, it depends on the summation fx and the summation fy. And that is why this direction is important. And its direction depends on the sign of the summation fx and summation fy. So I hope you have got this answer, 146 and 600 Newton. Now locate the quadrant. So you can consider this as a third step. So locate the quadrant for the resultant. So it will depend on the summation fx and summation fy. So as summation fx is positive, so I will draw one vector. So this is your summation fx. And summation fy, it is minus 600. So it is towards the negative x direction, sorry, negative y direction. So this is your summation fy. So one important point is, when you show the vector in the downward direction, then just write the positive value. So because downward means it is a negative. So do not write here again minus. Just write summation Fy. It is 600 Newton. So from the direction, when you consider this value in the calculation, then you will automatically take this value as a minus. So resultant, it will lie in the fourth quadrant. So this is the exact location of the resultant. So this is your R, that is equal to, now just we have to find out the R, we forgot that step. So find out the R value. Use the formula summation fx square plus summation fy square. So this value, it is equal to it is 617.6049. This is in Newton. So this is that value R. It is 617.6049. And this theta angle, generally we consider the angle with respect to x-axis for the resultant. So this is the theta angle for the resultant. So for the theta, we have the formula. To calculate theta, we will use tan inverse summation Fy divided by the summation Fx. So just put the value summation Fy and summation Fx. Just put the positive value. Because we already know the quadrant, it is a fourth quadrant. So just take this 600 and divide it by the 146. You will get the answer positive for theta, and this is the exact direction of the theta. So theta here, it is 76.28 degree. Okay, so have you got the same answer, 76? So if there is any mistake in the calculation, just tell me. Okay, so all of you must have got this answer. Theta is 76 and R is 617. So now we have to find out, determine the direction of motion. So what is the meaning of this resultant? If you apply forces in this direction and second force in this direction, then in which direction this cylinder will move? So the motion of the cylinder or any object, it depends on the direction of the resultant. So resultant motion will be in the same direction of the resultant. So on this diagram, I can show the resultant like this. So this is your resultant, and this is the angle with respect to x-axis. So because of these forces, this resultant, it will move in this direction. And why this is? Because there is a weight of 800 Newton. If this cylinder is a weightless, just assume there is no weight of this cylinder, then the motion would be somewhere in this direction. It will be the resultant of these two forces only. This value will be 0, and therefore your resultant motion will be in the upward direction. It may be in the first quadrant or maybe in the second quadrant. So I hope this concept is clear, how we decide the motion. So this type of problem, it has a practical application when we lift a heavy object by using a crane, and specifically by using a pulley arrangement which is connected to the crane. So this is a simplified diagram for that physical system. So is it clear to you, this problem? So you can give the reply, then I will proceed for the next. Okay, so we will start a new concept in the concurrent force system. So this is one special case, and that is called as a law of parallelogram. So what is basically a law of parallelogram? You can see the definition. The law of parallelogram of the forces states that if two vectors acting on a particle at the same time be represented in the magnitude and the direction by the two adjacent sides of the parallelogram drawn from a point, their resultant vector is represented in the magnitude and direction by the diagonal of the parallelogram drawn from the same point. So what is the meaning of this definition? If there are two forces acting on a particle at the same time instant, so let us take, this is a point, or we can say it is a particle, and we apply the two forces. This is one force and this is the second force on the same particle and at the same time instant. So this is a F1 and this force is F2. Then if we construct the parallelogram from F1 and F2, so that means to construct the parallelogram we have to draw one vector parallel to F1 and we have to draw one vector parallel to F2. So this will complete the parallelogram. So this is complete parallelogram. So if you want to find out the resultant of this F1 and F2, then this resultant can be represented by the diagonal of that parallelogram from the same point of the intersection. So this is nothing but the resultant R. So if there are two forces F1 and F2 acting at the same point, then the resultant R of these two forces can be shown as a diagonal of the parallelogram constructed by using F1 and F2. So I hope this point is clear. What is meaning of a law of parallelogram? And to calculate the resultant, so this is alpha. That means it is an angle between the F1 and F2, and theta is the angle of the resultant with respect to any one force. So let us take this is with respect to F1. So the resultant we can find out. by using this formula. R is equal to square root P square. So P square means this F1. So we can take this value as a P. F2, we can consider this as a Q. So P square plus Q square plus 2PQ cos of alpha. So alpha is the angle between the two forces, and the direction of the resultant R, it can be given by this formula. Theta is equal to tan inverse Q sin alpha divided by P plus Q cos alpha. So when we take this formula, then angle will be with respect to P force. I hope this concept is clear. So this is the formula for the angle of resultant, and this is the formula for the resultant. So this law we can use for the concurrent force system only if there are two forces acting at that point. Then and only then we can use the law of parallelogram. So this is a limitation for the law of parallelogram. There has to be two forces. And if there are more than two forces, then we can solve that problem by using a simple procedure, summation fx and summation fy. So I hope this point is clear. So on the law of parallelogram, we will solve one problem. Then we will understand how to use the law of parallelogram for the concurrent force system. Madan Patil, do you have any doubt? Okay, you want to note it down. Okay, you can note down this. Okay, just note down this. Then we will start with the problem. So by using problem, you will understand the exact application of law of parallelogram. So two forces acting on the bolt as shown in figure. So this is the bolt. The first force is 120 Newton. And the second force is 80 Newton. And the angle of 120 Newton, it is given with respect to the x-axis as a 30 degree. And for the 80 Newton, this angle is 45 degree. And question is, we have to find out the resultant of these two forces. So for this resultant calculation, we will use the law of parallelogram. As there are only two forces, then we can directly use the law of parallelogram. So when you use the law of parallelogram for the concurrent force system having two forces, then we need to draw a parallelogram passing through this 120 and this 80 Newton. So I will draw the figure. So this is the point where this 120 and 80 Newton are acting. So we will consider this force as a P because we have the formula in terms of P and Q. And second force is 80. So compared to 120, the vector size of 80 Newton will be small. So this is 80 Newton and assume this as a Q. Now draw the parallel line from this P parallel to Q and draw second line from this point. So I hope this point is clear how to construct the parallelogram. Now this point, it is a common point for 80 Newton and 120 Newton. So you can construct the resultant from this point along the diagonal of that parallelogram. So this is nothing but your resultant R. Now here angle given with respect to positive x-axis and with respect to negative x-axis. So this angle given, it is equal to 30 degree. And this is given, it is 45 degree. But if you refer the definition and this diagram, then we need the angle alpha between Q force and the P force. Then we can use this formula R is equal to P square Q square plus 2PQ cos alpha. So in this problem, that alpha angle is not given directly. So this total angle is alpha. So can anyone tell what is the value of alpha for this problem? Is it 105 degree? So to find out this alpha angle, this total will be 180 degree. So it is 180 minus 45 minus 30. So this is 45 plus 30, 75 degree. So 180 minus 75, this will be 105. So your alpha is 105 degree. Now use the formula of resultant for the law of parallelogram. It is P square plus Q square plus 2PQ cos of alpha, and this is equal to, just put the value of P, Q and alpha. You will directly get the value of resultant. So this is the use of parallelogram. You will get the quick answer if there are only two forces. So P value is 120, Q is 80, and cos of 105. So let's get the answer. So the value in the square root, it is 15830.674, and your resultant value R is 125.82. Okay, so we got the same answer, 125.82. And to find out the angle of resultant with respect to P force, we will assume this angle, it is theta. So we can compare this diagram with the standard diagram. So this is our theta, this is the resultant. Then we will use this formula, theta is equal to tan inverse Q, consider the opposite force, Q sin alpha divided by P plus Q cos alpha. So theta is equal to so Q is 80 sin alpha. So alpha, it is 105. P force is 120. So actually it is a tan theta. So theta will be tan inverse of this complete answer. So this answer is 0.778. So just get the answer, theta is equal to, so it is 37.89 degree. Yes, you can check the answer whether it is correct. So we can represent this theta in this diagram. So this is your horizontal axis. This is that point. This is 120. So this is 80. That is a Q force. This is P force. This is vertical line. No need to draw this line. This is just for your reference. This is the y-axis. This is the resultant. So if you construct the parallelogram, so this angle, it will be theta, that is equal to 37. Okay, so this is the use of law of parallelogram. If there are two forces, then we can use the law of parallelogram. So is it clear to you, this problem? So we will solve the one more problem on the law of parallelogram. Okay, so this is the statement. So this problem is again on the law of parallelogram. The statement given is find the magnitude of the forces P and Q such that if they act at right angle, their resultant is square root 34 Newton, and if they act at 60 degree, their resultant is 7 Newton. So we have to find out the two forces P and Q, and two conditions are given about their direction. So I will assume these forces are acting at point P. Suppose this is the point. And the first condition given, if the P and Q act at right angle, their resultant is square root 34. So consider the P force like this and the Q force perpendicular to the force P. So this is the first condition. In the second condition, they are acting at 60 degree. So this is the P force and this is the Q force. So this angle is 60 degree. And the information about the resultant is given. So when they are acting at right angle, R is equal to square root 34. And for second condition, R is equal to 7 Newton. So as the information about angle and the resultant is given, then we can directly use the formula of resultant. So consider the first case. Then write the formula R is equal to, it is square root P square plus Q square plus 2PQ cos of alpha. Now what is alpha here? Alpha means angle between the first and second force. So alpha here it is equal to 90 degree and R is equal to root 34. This is cos of 90. So you can simplify this equation as cos 90 is 0. So we will get, if you square both the sides, then it is 34. It is equal to P square plus Q square. So this will be your first equation. Now consider the second condition. For the second condition, your alpha is equal to 60 and R is equal to 7 Newton. So you can write the same formula R. Just I will put the value directly. R is equal to 7. It is equal to square root P square plus Q square plus 2PQ cos of 60. So you can find out the value of this complete cos 60. So if you square this, you will get the value. It is 49 is equal to this is P square Q square plus this 2 into cos 60 into PQ. So this will be only PQ. So this will be your second equation. Now from the first equation, put this value P square Q square is 34. So this is 49 is equal to 34 plus PQ. So we will get PQ is equal to this is 15, and then you write Q is equal to 15 by P, and then you can put this value in this equation. Okay, so we will stop here.